Welcome everyone. In today's video, we're going to talk about MCP or Model Context Protocol. We will look at what it is, how it works, and how it applies to healthcare. I will be walking you through some of the foundational principles, and then we'll look at a demo, and then we'll also kind of look at a working code of an MCP server. Now, before we do the deep dive, it might be helpful to start with something that we are all probably familiar with, and that is ChatGPT. When you are using ChatGPT, there are two main components involved. There is the app that you interact with, that could be the browser or the app on your phone or the app on the desktop. And then there is the model, the large language model in the backend. You might have noticed that you can actually change the model that you're using from the ChatGPT user interface itself. This is the same core principle that applies to any LLM based applications. However, there is also another component that works behind the scenes to make all this possible. And that is called the client in the MCP terminology, or also more generically just used as the word agent. So the agent or the client is the component that is connecting the app with the LLM. And that's where is making all the magic happen. Now, to understand how all of that applies to MCP and it works, let's start with a very common example of how typically AI scenarios come into play in a healthcare settings. Let's just say we have a clinician using a Smart on Fire app. It doesn't need to be a Smart on Fire app. It can be any app that connects to the EHR. For today's demo, we'll just say that it's a Fire-based app. The app connects to the EHR using a Fire interface, and it delivers some functionality on top of an EHR. Now, a clinician comes in and says that I want to interact with this application with an interface similar to ChatGPT. Instead of going through multiple clicks to find information, what if I could just say, how old is Alice? Or show me Alice's latest lab results, or give me a summary of Alice. This kind of interaction is now becoming common in other apps, and the question is, how do we bring it into healthcare? So, as we discussed in the ChatGPT example, to support this use case, the app will need to add some kind of a chat feature. Behind the scenes, the app must also connect to an LLM and respond to those queries. As I explained before, it's not the app that actually directly connects to the LLM. Instead, it will embed a client or an agent that acts as the bridge between the app and the LLM. Again, this is a very important concept in the MCP terminology to understand that it is the client that is interacting with the LLM. So at this point, we have two main components. The app, which is also referred to as the host, which basically is used by the clinician. And then we have a client, which is embedded in the app that handles the communication with the LLM. Now, in order for this LLM to answer questions that are related to patient data, it needs to access the Fire server. That is where the star of the show, our MCP server, comes into play. An MCP server acts as a wrapper around a Fire server or any other system, as we'll talk about, and exposes the functionalities as a set of tools that an LLM can understand. In simple terms, MCP is defining a standardized ways for LLMs to connect to different backend services. This can be Fire servers, this can be billing systems, this can be communication systems, or any other systems in that organization. The key thing here is that once that MCP server is defined, it provides a very simple way to connect with that client that is embedded into the app. So what exactly is the problem that we solved here? Before MCP came along, every LLM provider has its own way of connecting to external tools and services. There was no standardization. With MCP, any LLM, whether it is from OpenAI, Claude, or many others, can now work with any MCP compliant server. And it's not just the LLMs that are changeable now. Any system or any application can now expose its services as an MCP server. There are already hundreds of systems out there that are now exposing their features as MCP servers. And this is kind of where it all comes together. This interoperability is very powerful because it allows developers to build LLM ready apps that can be plugged into any LLM on one side, and it can connect to any healthcare service or any non-healthcare service or any systems in the organizations, ultimately making MCP such a connector that can basically bring all the different functionalities into the apps. Now, that is at a very high level. There is a lot happening behind the scenes from the time a prompt is typed to the point where the final answer is generated. So to walk you through all of those details, let's go into some of the details of a prompt lifecycle. So in order to do that, what we are going to do is we are only going to focus on the main actors from where the prompt has already landed in the app and how does it actually turn it into the response. So let's take a deeper look at it. So the process actually starts even before the first prompt is typed. What the agent is doing behind the scenes is it's going to make a query to the MCP server to ask to know that what tools does the MCP server support. And the MCP server will send back a set of tools like a toolbox to tell the client that these are the different features, these are the different tools that I can support. And we'll look at like what exactly these tools are in a demo and kind of how this metadata is supplied. But the key to understand here is that the agent now has a list of tools that it knows that the MCP server it is connecting to can supply. So then what it does is it will combine the prompt that it had and it will take the entire list of tools and it sends it to the LLM. The LLM basically looks at the tools and looks at the prompts and it decides that I want to use one or more out of those tools in order to respond to this query. In the example that we just saw, it realized that it was asking for Alice's age. So it's probably going to send back that Alice has a name. It's going to probably send some other queries. But that's where the LLM is smart, where looking at the tools, it can decide what kind of list that I need to send it back to the client. The client will then take that list and the tool that the LLM has asked to be invoked, and it will send it to the MCP server. The MCP server will take that and will send the list of queries that it created, which has been converted into the way that the tool, in this case, the FHIR server, can understand. The FHIR server will actually execute the query and it will return the results to the MCP server. Now the MCP server will send that result back to the client, and the client is going to take all of that result and send it back to the LLM. The LLM already had the prompt and now it has received more information to answer that prompt in real time from a tool, which was basically the FHIR server. It will basically combine all of that and send the result back to the client. And the client will deliver that result to the app interface along with the other features that the app supports. So this is the complete life cycle of how that prompt turns into a response that is also has information from the latest data. Don't worry if it sounds too overwhelming. It's actually pretty simple when it works behind the scenes. And to show that, I'm going to now jump into a real demo to show how it all works and comes together. Okay, for the demo today, I will actually be using my local instance. That's because I want to show you some features behind the scenes and some of the code of the MCP server. But you can follow all along, and most of these features are available already in our production environment too. If you are not familiar with Meldarx, or if you have never created an account before, you can actually just go to app.meldarx.com, click on the create an account link from there, and you can go ahead and set up your account. All the steps that I'm showing today can be completed on the free basic account. Okay, so here I am logged in. This is the same interface that you will see after you have created the account and logged in. I don't have any workspaces. I don't have anything created so far. So the first thing I'll do is I'm going to go ahead and create a workspace. And a workspace is basically a FHIR server. That's the first component that we need. So I'm just going to go type a name in here and go ahead and create that workspace. So with that, I have created my first workspace. To work with some data, we will need some patients into the workspace. So what I'm going to do is I'm going to go to import data. I'm going to go to sample data, and we're just going to start with one patient. We can import other patients later, or you can try it out, but I'm just going to start with one patient to get started with. So if I wait for a few seconds and I refresh it, we'll see that that patient will show up in here in a second. While that is showing up, the next step that we have to do from here is provision a model. So I'm going to show you a way where you can actually go and provision models for free. If you have not heard about it, it's the thing called GitHub Models, where you can actually create models and then use them in your code from API or directly from GitHub. So let's just first make sure this patient has been created. So we have the patient in there. So I'm going to go to github.com marketplace models. Just go ahead and select any model. It really doesn't matter. And then what you want to do is you want to go to this button called use this model, and you are going to say get developer key. It's going to walk you through some steps where ultimately you will get a token. Copy that token and save it with you. You need to give very minimal permissions to that token. All it needs is just a read permission to the public repos, and that is enough for what we are doing. Once you have that, you're going to come back to your MeldRx portal and you're going to go into this AI section, and I'm going to go into models and I'm going to copy that token in here. Okay, I'm going to set that to enabled and then I'm going to go ahead and save. So what this does is it will basically configure some models that are ready to be used from MeldRx, and I can go ahead and check them in the playground. So if I go in the playground, you'll see that I have some different models. And what I can do is I'm going to go select one of the models. Let's just say I'm going to select GPT-4o, and then I can go ahead and type a question in there. We'll just say, who are you to start with? And if I click submit, you'll basically see that it will communicate like I am talking to GPT-4 on ChatGPT. So we are basically ready with the first two steps where we have a Fire server and we have a model that is configured. Now what I'm going to do is I'm going to try to ask a question about data that is in the Fire server that is configured in here. So let me just say, how old is Alice? Okay. So I'm going to go ahead and click submit. And it's going to tell me that it needs Alice's last name. So I'm going to just say Alice Newman. And again, this is kind of how you can design the tool. I'll show you a different version where we can even make it work with just the first name. So if I go and click how old is Alice Newman, and if I type it, you'll see that Alice Newman is 55 years old. And if I go back to, so I'm just going to open it in a new tab so that we can look at the patient data and this together. She is basically 55 years old. I could have obviously gone in there too, but the idea here is that you get that information from there. Now, what happened in this case was that by default in MeldRx, we have a set of tools that are already activated, and you can see them from here on MCP server, and you can see that we have the default MCP server already activated. And one of those default activations is a tool which allows you to get patient age based on the first name and last name. So let me see if I can basically turn this off, and I'm going to save it here. And if I go back to the AI playground and I'm going to ask it the same question from GPT-4o to say, how old is Alice? You'll see that it basically says it doesn't know anything about Alice. Is it Alice your neighbor? Is it Alice someone? It's basically lost the context. And this is the key difference between talking to a LLM and talking to an LLM that has an MCP server enabled, that now that LLM has full context in real time where it can connect to and get more information to answer the questions. Okay, so what I showed just now was that you have a Fire server that has exposed its own MCP server, and I am able to communicate with that Fire server. Let's take it one step forward now. I'm going to actually show you how you can actually connect a Fire server to a third party or an independent MCP server. So I have a local MCP server that I am running on my local machine. And the first thing that you usually do when you are testing an MCP server is a tool called the MCP inspector. So I'm going to go to this tool. It's running on my local machine. The documentation is available on the MCP website. And what I'm going to do is I'm just going to copy the URL where I'm running this locally. I'm going to connect with it, and it will connect and say that it has found the tool. And then I'm going to click on this button to say that list me the tool. So this will give you an idea kind of what does the word tool really mean. So in this case, you will see that it's telling me that there are two tools. One tool is called Find Patient by ID or Find Patient ID. And this is the tool that will take a first name and a last name and return me an ID. And the second tool is a read FHIR resource, which takes the ID of a FHIR resource and it will basically return me the details of that FHIR resource. Now, the key thing to understand in here is this text that you are seeing in here is not for us or for the APIs. This is the metadata that will be passed to the LLM along with the prompt. So when we say, get me the age or get me details of Alice, it will know that, okay, I'm talking about a patient. It can read through this metadata and decide that which is the tool I want to call and what information I want to kind of, pass to it. And how does it do it? It's basically based on all the prompt that is built in here. So I'm going to go show a little bit of code in here. And again, don't worry about it if you don't understand all of it. And as I said, I'm going to be using the .NET, version of it. There is also a TypeScript version that we are working on that will release that you can use to, test it too. So what I'm going to show you is the two tools and the key components of those two tools. And the main thing here is this description of that tool that we have in here. This is what the LLM will be able to read when we send this metadata, and it will know which one to call. So for the patient ID tool, what I'm saying is finds the ID of a patient. If the patient context already exists, do not use the first name and last name, but otherwise use the first name and the last name to find it. What it means really here is that if we are connecting with a Smart on FHIR app and the app is already working in a patient context, it can basically find out that the patient ID is already there and just return that ID for the next call. But if it is not there, it will tell you that it needs the first name and the last name. And then on the other tool, basically what we are telling is that, again, you are to read a FHIR resource. I'm going to make a call to say that, here is a particular ID, here is the details that I want you to kind of get me back, and it will kind of combine all those together and get it back to me. Again, this will reply an ID. And what I want to show in there is that how the LLM is actually smart enough to combine these two tools into one request and return the results. So I have this running locally. So I'm going to go back to my application. And what I'm going to do is I'm going to go and say that I actually want to configure an external MCP server. We have already turned on our default one. We can work with multiple MCP servers in here, but I'm just going to go ahead and type to say that I want to work with that external one. So I'm going to just copy this URL from here. I'm going to copy that in here. It's going to be an SSE, and I'm going to say right now it is an open server. So we can actually, connect with secured servers too. And I'm just going to click on test. And what this test basically does is it makes sure that it can make the connection. And now it can say that, okay, these are the tools that it found. So that means that MCP server is working, and I can go ahead and click save on it. So with that MCP server added to my FHIR server now, I'm going to go back to the playground and I'm going to ask a different question in here. So I'm going to go to GPT-4o again, and I'm going to ask a question in here is like, give me details on Alice Newman. Okay, so if I click on it and I'll wait for some time, so it's actually going to execute the tools, and we will be able to see that it actually has executed. So you can see that it went in there. It has actually, got the details of Alice Newman from the patient resource and is listing them out there. Now, again, this is a very, very simple example, but the key thing here is to see that you can actually see that it actually said that, okay, which are the tools that it read, and all of those tools have been utilized by this FHIR server to connect and get me that data back. So this is a very simple example of a basic tool that we are using. The possibilities are endless here because you can build more and more smarter and smarter tools which ultimately know how to connect to the underlying service, in this case the FHIR server, but it can be any of them, and then bring all those results together. We have all seen the power of ChatGPT, and all of that generative power can be brought together with real-time data and kind of brought together in that system. I want to show you one last piece before we go out of here. So I'm going to go into patients back, and I'm going to go into actually Alice Newman's chart in here. So, and I'm going to go into a playground that is within the Alice Newman's chart. And I'm going to select a model in here. So this is a similar kind of a idea that I have a playground to work with, but I'm going to go in there and type the same message, but it's going to be a little different message. I'm going to just say, summarize the details, patient details. Okay. And I'm just going to go and click submit in here. Okay, so I will get a similar response, But what you notice in here is that I never actually specified Alice, or I didn't say what patient I'm talking about. And the reason is because I'm in Alice Newman's chart and I can actually get that information directly from the tool. And that's kind of how the tool is designed. So if I go into the patient ID tool, it knows that it's going to either get a first name, last name, but then it can also look at the context of the the token that it has received, and from there it can decide that okay, that patient ID was passed to me. In this case, we are passing it as a Smart on Fire token parameter, and then it can basically extract it from there, and then it doesn't need actually the full information. Okay, so everything that I showed you so far was using a default app. The idea here is that you can actually use all this functionality from any app. So all of the functionality is also available through APIs. So if you go to docs.maildirect.com, you can actually go to the AI section, and all the calls that I was making from the app are also available, including getting the model details, including getting the inference text or other calls from there too. And the idea here is again that you can build any apps that are connected to a Fire server, connected to an MCP server, and both of them together, and bring different scenarios together. Hopefully that gave you a good understanding of what an MCP server is and how it works for healthcare. Everything that I showed in the video today is available for you to try. Some of the features are still limited to the accelerator participants, but we will be rolling them all out within the next couple of weeks. If you are interested in the accelerator program, please reach out to us. Also, we will be starting a new initiative around Memorial Day for designing reusable MCP servers for healthcare. We are doing this as an open source project where we will be sharing some templates in .NET and TypeScript to start with, and then we'll probably write it in other languages too. And we are really looking for collaborators to work together with us. So if you are interested in that, please reach out to me or to anyone in our team, and we'll love to talk. Thank you again for watching. See you next time.